Moving on to Chapter 5. Chapter 5 is all about trigonometry. But before we do any sort of official trigonometry and talk about sines and cosines and tangents and all that amazing stuff, we gotta build up a little bit of information first. And in particular, we need to talk about angles. So trigonometry is sort of all about angles. In some sense, it's kind of the math of angles to a certain extent, and angles are kind of unique because what angles measure rotation. So that is, instead of measuring like a distance from like point A to point B, you're actually sort of measuring, right, how much something turns. Sort of a typical angle picture would maybe look something kind of like this, and what we're trying to represent is the rotation, this spinning motion, right? So not a distance, but actually sort of an amount of turning. You can turn two directions, clockwise and counterclockwise, and that for us will be in the opposite order, a positive and a negative rotation. But let's just get a couple like ground things first. So the way we represent an angle is this. It's sort of this intersection of like two rays. A ray is like a half line, right? So it's heading out in either direction. This side is what we call the initial side, meaning the sort of like starting side. Start. The like side up here, right? So the idea is that we're sort of starting in this position, we're rotating up to here. This is going to be what we call the terminal side. Terminal meaning like ending side, like the terminal stop on the subway. Right, so you're starting here and you're ending here and you're rotating like this. In the middle, this sort of like pivot point is what we call the vertex. Right, so that's sort of where we're like rotating from. And we'll mark a little like arc here with an arrow on it to sort of indicate which direction we're rotating. So if we rotate in this direction, so this is right counterclockwise. So that's going to be positive rotation. If we go clockwise, that's going to be negative rotation. Right. So counterclockwise, like the angle we have here. Sort of up and to the left. And so negative rotation would be rotating down and to the left. So we maybe get something that looks a little bit like this. It's important to draw that arc, right, especially with the arrow. I guess you don't technically need the arrow. I guess I draw the arrow, but you don't need it. But the arc is super important, right, because if I drew, for example, like the same initial and like terminal side, so like note, we definitely need the arc when we draw this, because if I just like draw any old angle like so, I could essentially get like two different versions or more versions of the rotation here. I could sort of rotate like this way, that would sort of be the positive version. Or in theory, I could keep those same sides and I could sort of draw an angle rotating all the way around from the other side, and this would be a negative version. These are going to be what we call coterminal angles. We'll come back to this. But what that means is they're angles that sort of can be represented by the same arcs, the same like side lengths, but the rotation is different, right? So partially the picture is the same, that the sort of ending position is the same, like terminal position is the same, but how you get there is a little bit different. So we have angle measure. We're measuring this rotation. We're saying it's different than having like a distance, right, from point A to point B. So we're not really going to measure it in, inches or feet or something like that. But we do have units. And the sort of the most common, just like day-to-day units, would be degrees. So measure an angle. So like option 1 is degrees. And so measuring an angle in degrees, again, like I said, this is kind of the most common, just like day-to-day type of measure. And what we'll sort of use in some sense as a reference is like one full rotation is really kind of what we're going to have as our baseline. If you think about rotating, one of the things that's sort of interesting and unique about it, right, is if you rotate around, as you spin, right, you obviously sort of point all different directions. If you think of this in terms of a compass or something, right, you sort of east, north, west, south, and then what happens eventually is you spin all the way like back around, and you're pointing east again. You end up exactly where you started, right? So if you say, right, I turned around and I did a 360. 360 degrees is the measure we use to indicate an angle that's turned all the way around. So if I take this and I went all the way around, that would be, right, 360 degrees. So one full rotation is 360. From there, what we can do is break it up, right? So 360 is all the way around. If you turn 360 degrees, you're facing back where you started. If you do a 180, right? If you turn 180 degrees, that's half of 360. And so what's going to happen then is you're going to rotate half of the way around, and you'll be facing the exact opposite direction, right? So 180 degrees is a half rotation, is half of the way around. I don't know if that's showing up as an 8. 180. And from here, right, you can kind of imagine, you can obviously sort of break this down as much as you want. 360, right, is sort of a medium big number. I mean, you could break it down to 1 degree or even much less if you wanted to. That would be a very, very small amount of rotation. So obviously a half rotation is 180. If you did a quarter turn, a quarter rotation, that's going to be a 90 degree angle. Hey Max, you coming up? Maybe not. So this guy is 90 degrees. This is here. Don't worry, guys. I've taken all the beverages away. The cat cannot destroy anything. Hey, bud. Helping out. So 90 degrees, right, is sort of straight up. It's also what we would mark sometimes with a little, like a corner angle. We'll be revisiting all these things. You could break it down even further, right? We're going to do lots of different examples, but if you did, a half. Again, 45, right? So 45, if a 90 degree is sort of a quarter rotation, 45 would be like an eighth of the way around, right? So you can obviously break this down sort of further and further and further, and you can sort of keep going as much as you want. Common ones, right? 360, right? 0 degrees would be sort of no rotation. 90 degrees is this sort of quarter rotation, this like a corner angle. 180 halfway around. You could kind of fill in the gaps if you want. This would be, right, 90 to 180 plus another 90. If you went down to here, this would be 270 degrees. You have a space to mark all these arcs. Yep. You could go from there. So option 1 for measuring angles is to just measure them in degrees. Option 2 is a very like math focused option. That's what we call radians. And so we're measuring the same thing. We're still measuring the rotation, right? We're measuring the same thing. We're just using a different unit. What's unique about radians is we sometimes call them a unit-less measure. See? So what that means is degrees. I sort of wrote this without even necessarily drawing attention to it, but the units for degrees, right, we're using this little circle up in this sort of like exponent position, like a superscript. Radians are sort of what we call a unit-less measure. So we end up using radians a lot in math because instead of trying to do calculations where all of a sudden you're sort of getting this degrees in here as a unit, if you do a unit-less measure like radians, you don't have to worry about doing any sort of like conversions or having it affect your other stuff. So radians will work with other math numbers. And so what we need to know for radians then is, okay, so like what's our sort of standard measure? What we're going to do is if we go, same kind of thing, if we start and go like all the way around, so it would have been 360 degrees, in radians is what we call 2 pi. This is essentially, I mean, it means 2 times pi, right? 2 times the number pi. The circumference of a circle is 2 times pi times the radius. So in some sense, this kind of syncs up with, you know, what would be the radius on a circle where I'm sorry, what would be the circumference on a radius? What would be the circumference on a circle where the radius was 1? That's what we're going to call the unit circle, which will come up later. So radians, in some sense, are syncing up with the sort of distance around the edge of a circle that has radius 1. But again, the important thing is we're not really thinking of this in terms of units. If we did, you know, what would be the equivalent of like 180 degrees if we did the angle that goes like straight across? So if this is 2 times pi, then a half of that would be 1 pi. We'll just call that pi, right? If we sort of cut that in half again and did, you know, what would be the version of like a 90 degree angle? So that's 2 pi, this is 1 pi, this would be a half pi, so we'll call that pi over 2, right? Just sort of cutting this down. If we cut that in half again, what we'd end up with is then 1/4 pi, right? This is 2, this is 1, this is 1/2, this is 1/4. You can imagine going down to, you know, 1/8 and 1/16 and stuff, right? If we filled in this sort of 270, in some sense, each of these 90 degree angles is 1/2 pi of rotation. So this is sort of 1/2, this is 2 halves is 1, right? 2 over 2. This would be 3 halves, this would be like 1 and 1/2. So this would be 3 halves pi, we call this 3 pi over 2, right? So we can sort of mark these same angles and draw these same pictures, and we can sort of get these measurements either in degrees or we can get these measurements in radians. So this is a starting point. This is just to try to get a little bit of a visual going. What we're going to do next is actually set up and do some conversions between degree measure and radian measure.